Hello, everyone. Please settle down. So, how are you? Yeah? Good. Heard it was like a wild night last night. I hope I won't be too boring. I will be little bit technical at times. Sorry. That's what developers do. Anyways, so my name is Marco, and I am a developer in the core Q&A team at Stack Overflow. That means, well, first of all, do you know Stack Overflow? The site? Yes. Okay, good. So I work in the team that basically makes sure that you see Stack Overflow when you have programming questions. And this talk is going to be about the architecture of Stack Overflow and performance of Stack Overflow, which is very, very closely related in our case. So just as a complete experiment, if any of you wants to, you can scan this thing and you can follow along the slides on your computer, or so I can pretend that you're actually interested when you're watching stuff. Anyways, I don't know if it works, never tried it, so. Anyways, done? Look how many people do that. Okay, so we're going to talk about architecture. And I looked up on the internet what architecture means. And basically, it turns out, unsurprisingly, that it means the art and practice of designing and building structures, especially habitable ones, but in software engineering, it's probably they're not habitable, but they're still structures. And so, the first book that we have about architecture is from the 1st century after Christ. And it basically identifies 3 different key features of a good architecture. One is durability. Okay, these are translated to today's terms, but durability, that means a building should not fall down, unsurprisingly, and that also means that a site should not fall down, unsurprisingly. Utility, so whatever you build needs to be fit for purpose and do what it's meant to do. And interestingly, it's about beauty. And this is a nice thing, because what does beauty mean in software architecture? Well, it can mean many different things. It's an aesthetic choice, of course. In our case, this part means having a system that is really high performance. So performance for us is a key architectural feature. Another thing that is very important to understand, so you go to your architect and you say, okay, Mr. Architect, can you build me a church? Right? And the first thing that your architect is going to ask you is, do you want this kind of church or this kind of church? The size is very, very important. So optimizing optimizing for size is a very important thing. And it means that the architecture that you're going to build is going to be different, whether you're building for 5 people, 5,000, 5 billion. It's a completely different thing. And you shouldn't build, this kind of church when you need the other kind of church. It doesn't make any sense. So we are saying about performance, right? So performance has a really, really crappy definition in English, which means the ability to perform, which doesn't mean anything. And perform also doesn't mean anything, it means do something. So it's related to efficiency, though. The ability to do something or produce something without wasting materials, energy, labor, and so on. And one very good way, and one process which is very, very efficient is the process of scientific discovery, the scientific method. Okay, don't read all of it, but look at this purple stuff here, these 3 small circles here. Okay, that's the key point about scientific method, right? So what do? You develop testable predictions, you gather data, and you analyze. Yeah, and then repeat. So what you do is you say, okay, I want to see if this antibiotic works, right? So first of all, I have a list of possible antibiotics, and I choose the one that's most likely to work. Then I run an experiment and I see if it works. And then, I compare the different results and see which ones works best. And then maybe I can think about the next antibiotic based on what I know. So basically, there is this kind of loop. And I put it here. It's going to appear a number of times in this presentation. It's a key concept, okay? So if you want to optimize and if you want to build for performance, you need to have loops. And these loops need to be tight, okay? So you build, you measure, you analyze. And the faster you can do this, more adaptable you are, the faster you can adapt, the faster you can build, and the faster you can grow. And to give you an example of what this means for us, I've been giving this talk, or a talk similar to this one, since I joined Stack Overflow, and that's in 2013. So when I joined, we had around 100 sites. Stack Overflow is actually a network of sites. There are sites about everything, from cooking to English to I2P to whatever, religion. Anyway, so we're around 100 sites. Now we are 160 sites. So 60% growth since I was there, and since I started giving this talk. If you look at the page views, from 2013, we were around 400. The first time I did this talk, we had 400 million page views per month. Now we're close to 800 million. And this is our infrastructure. So when I started, we had 9 web servers, and now we have 9 web servers. It's just a result of this. Of course, that's because we care about performance, and we spend a lot of time optimizing that. By the way, the number of page views, actually, of uniques that we have, says more or less Stack Overflow is the 17th, 18th network in the US. Unfortunately, this comes from Quantcast. Quantcast screws up our own case, and that's why we're not in that list, because it separates Stack Overflow from each site, and therefore the sums don't add up. But if you add up all our uniques, there are 39 millions, more or less, per month. And speaking about screw-ups of Quantcast, I don't know if anybody heard about this news. that North Korea has got 28 websites. So it's like, yeah. So it's got like a great internet presence, right? So you can imagine, this is, looking at pictures of cats, I guess. But actually, according to Quantcast, and I don't think this is true, they're probably looking at Stack Overflow because we are site number 1, number 2, number 4. This is in North Korea. With 200 uniques a month. Yeah, so I don't know, crazy stuff. Don't trust Quantcast. Or do trust them, but not about North Korea. Anyway, so we were saying build, measure, and analyze. Let's talk about hardware. Okay, so this is a server rack. As I said, there are 9 web servers. There are a few additional servers. We have 4 DB servers and blah, blah, blah. So that's something you build. This is how we monitor it. We have built our own custom solution. It's an open source. It's called Observer. And basically, it allows us to see in real time what's the load on our machines, if anything is falling down. If you look at top right, you can see that we can actually monitor SQL servers. We can see the worst performing queries. Redis, we can see how many ops per second we are doing, Elastic Network, and so on. Also, you can notice a couple of funny things about this. These are web servers here. As you can see, they're running around 5–7%. So yes, we have 9 web servers, but they're used at 5%. those are our SQL servers. Those also tend to be around 10%. And this is common with all our machines. Our Redis infrastructure is way below 2% CPU. RAM doesn't really count, right? Because if you use, for example, SQL Server, it's going to use all your RAM. It doesn't matter how much you put. You need to put the right amount, of course. In fact, you know, the Stack Overflow database has got like 750 gigabytes of RAM. So it's a pretty big machine. And also the web servers, we use the RAM for caching. Yeah, we do caching, we cache the hell out of everything. And so they need quite a lot of RAM. But these are not incredible machines. They're pretty big, better than your average cloud, which is why we don't use the cloud normally, because they don't have this kind of machines. And if they do, they cost more, way more than building them. And then, so after we measure, we analyze. Yeah, we predict the growth. So one of the most important things that we need to do is make sure we don't run out of this space, for example. So we run these calculations. So our cycle looks like this, right? Build the servers, measure performance, and analyze and predict. So this is the architecture. Brief aside. As you can see, there are two load balancers based on HTTP proxies and running on CentOS. We have 9 web servers. And then we have a hell of a lot of caching running on Redis. We have Elasticsearch that you use for the search on the site and a bunch of other things. We have the databases, which are those 4 boxes. And then we have the service tiers, which is a specialized, it's something that actually came out of this measuring, right? One of the problems that we had was that searching for questions by tag was very, very expensive. So first we created a super cool hack by using full text search in order to search for tags. And that worked like maybe the first year or so. Then that stopped performing, so we started having indexes in memory, and then that stopped performing because of garbage collection. So we separated the indexes and we moved them to a service tier, which is that one. And now we're optimizing that to run on GPUs. So again, build, measure, analyze. I'm going to obsess you with this. Okay, so another example that how we do this is we write code, of course. But then we measure. So on the top right, you can see Mini Profiler. It's an open source tool that runs on .NET or Ruby and JavaScript, I think. And it allows you to profile every request or a subset of the requests that go to your site. In our case, for example, is profiling all the requests for me because I'm a developer. So every time I go to Stack Overflow, I can see a page, I can see what happened, right? So how is a question page composed? Well, you can see, you know, we look up the account and then load the answers of the question, to the question, get the questions, load the answers, get the comments, and so. A bunch of steps in there, and for each of these steps, I can see how long it took, I can see how much SQL, how long the SQL took, and I can actually dig in this window and see the SQL queries. So they are written in a way in which I can copy and paste them inside the database shell, and they just run, and I can replicate everything that I need to do. So there is a lot of attention on performance and, you know, seeing what happens when you deploy stuff. And of course, after we measure, we analyze. And most of this data, not this amount of detail, but maybe the roll-ups, the totals by column, are stored for every request. So I can draw graphs like this one. This is a question page, honestly, on a really good day. It's not that good normally, but okay, so this is the time. This is 10 milliseconds, and this is the request, the blue. So to render a page, time to first byte for a question page, it takes around 10 milliseconds or less for our most popular pages. And if you look at the question, at the distribution of times, Redis, the Redis requests, so the cache requests, run around. So this is database. Database calls are between 2 and 3 milliseconds, and Redis is even unmeasurable, between 0 and 1. So it's important to know these things. It's important to know, what people are seeing. I mean, especially you want to look at this stuff here, right? The people that are suffering. And there are always going to be some outliers, of course, and you want to make them not too big. You want to make, all the hills move left. And you can do that by trying out new things, new optimization strategies, and so on, and then running the test again. Okay, so again, another cycle. Also, I was saying before that it's very important, not only that these cycles are efficient, right, and you run them, but it's important to run them fast. And the key in this particular example, so in the case of the servers, of course, buy new hardware and specify new hardware and upgrading it is very expensive. So we do that maybe once every year. So there's really little we can do there to optimize constantly. But in this case, we can optimize like with one deployment. So the number of deployments per day is very important to us. In fact, we measure it, and there you go. So we run, so these are production deployments. That means permanent stuff that is there. And as you can see, we were around maybe 3 when I joined. Now we are 4.5, something like that. So tell me I just have 1 minute, so I'm gonna run. Other stuff. How do we do this? Well, first thing we do caching. We do a lot of caching. We have a highly optimized code that allows you to write the whole stack, the whole vertical slice of a feature in I just got 5 more minutes. The old vertical slice of a feature in one request. So you see everything there. We don't have layers, right? This basically is a model. It doesn't have a repository. It doesn't have anything. The SQL is next to the classes. Everything is optimized, and there's caching in there as well. Other stuff. We have particular problems, right? Because when you have to do hundreds of millions of requests per month, you tend to run into some peculiar problems. For example, the garbage collector is not built for applications of this size, of this size of performance. It's built for much smaller things. And in our case, it fails all the time. And what it means is there are just too many objects created, and the garbage collector sort of chokes. So, for example, this is, again, is a question page. It's a very popular question because it's funny, probably. Top right, there are some tabs. Those tabs are static. The only thing in there is that we need to create some classes in order to run a component that generates them. And as you can see, so this is the code behind, and you can see that we're actually caching those 4 classes that are used to generate these tabs through a component, even though they don't access a DB, they don't do anything suspicious, and they don't do anything slow. So it's not a matter of speed, it's a matter of not creating new instances, because otherwise the garbage collector chokes on us. And why is that? So garbage collection, are you all familiar with the deep mysteries of garbage collection, so I can skip this? Does anybody want a quick refresher? Okay, someone does, okay. So very quickly, so basically in C, you create your own objects and you destroy your own objects, and that's a pain. And so in modern languages like Java or C# or JavaScript, you don't do that. you just create objects, and then when they get out of scope, then they're not linked by anything, they just disappear by magic. Well, it's not by magic, it's because of garbage collection, which is a process that runs in the background, and at a certain intervals, it just tries to see what of the garbage or the objects that you created are not used anymore, and it tries to clean them up. The more you clean them, the more time it takes. Yes, this is not exactly correct, but it is correct enough. So if you have a very, very popular page or something that you do over and over and over, and you create objects in there, you're going to create a ton of objects, and this background thread, which you should never see, it should be invisible, it starts like stalling your application and making everything slow. So performance sucks, and we need to take care of it all the time. Another thing that we do, crazy stuff, you notice that underscore S there. This appears everywhere, for example, in a page like this. So what this does is creates a string, and this string is localized. So if you see this in English, you're going to see it in English. If it's in Japanese, you're going to see it in Japanese. So normally, you either go and read this from a resource file, or you go and read this from the database. These are two standard industry standards for doing this kind of work. The way we did it is we actually put all the strings in a database, but then we bake them inside the compiled code. So basically, we go from this code to something that, once they compiled, is like this. So it's a list of writing literal things to the browser, and there is in the middle here, there is just a call to a generated ugly name method, and the method, as you can see, has literally the strings baked in. So these come from the DB and they're compiled in. This actually makes the site much faster. And in order to do that, we needed to build our own compiler for web pages, which is based on Roslyn, which is a Microsoft technology. And you can see there the effect on our build times. Actually, when we built it, we halved our build time. Other stuff, crazies, string builder. String builder is a .NET mutable string. It's too slow for us. It creates one extra instance when you create one. So we actually had to avoid instantiating too many of these, and we pulled them out. Other stuff we cannot do, dependency injection, is a wonderful world when you can do stuff like this, right? So you want to get an order, you need to get a repository, and the repository gets you the order, and there is a magic container that gets you all that you need. And this is fantastic because you're decoupling, right? So you just know that you want to have order E25, but a set of operations which you're not aware about are automatically executed, which is fantastic from the point of view of architecture, but not so fantastic from the point of view of performance and garbage collection, because typically these kind of garbage collections, they either make you create a bunch of new instances every time, or they store singletons, which are also bad for garbage collections for another reason. So in any case, we can't use that, and the result of that is that we write code like the ones I showed before, where everything is just on one method. Other stuff, look at our source code. So we only have 10 projects and around 100,000 lines of code and very, very few tests. The reason is, number one, that we write a lot of open source libraries. So when something is stable enough, we write a library, we open source it to the world, it's not part of the project anymore. Number of lines of code goes down and everybody's happy. But to talk about the unit tests, again, build, measure, analyze. So what happens? Well, first you build, right? So you don't test your code and you put it in production. That's exactly what we do. And then, when it's in production on a canary site, our users who are developers will find the bugs, so measure. And then they give you a solution to the bugs. So analyze. Right? Build, works for us. Okay, more build, measure, analyze, almost there. Okay, no, this is not a line here. So it's not build, measure, analyze, but 3 things are related: people, tools, and code. So I was looking for hackers. This is the first thing that came out, but we don't really want to hire people that know how to hack the Gibson. So this is the kind of hackers we're talking about. So we want to hire people that can code and let them code. So people are important. Their time is important. By the way, if you want to hire Arcus, this is a shameless plug. We do that, and that's how we monetize. career.stackoverflow.com. You can hire the best hackers. Anyways, then once you hire these people, you need to give them the proper tools so they can do the job the best of their ability. This is one typical setup. This is Jeff Atwood's, but we are all with 3 monitors. And then, these people will produce your high-level, your Bose mod code, let them play, and they will do stuff which is pretty much hardcore. So, again, you hire the best people you can find, or people who are really passionate, and then give them the tools, and they give you the best code, and the best code is going to free up their time, because, of course, they wrote the most efficient code, so you need less people, and so on and so on. It's another cycle that you need to optimize. So in conclusion, sorry it was long. Okay, so first of all, performance is a feature, not a luxury. Remember the three things that make up architecture: beauty or performance is actually important and is not just a side effect. In order to have performance, you need to have cycles, and you need to control your cycles and make sure that they are tight as possible and they produce the best results. The results that you get are going to be very specific to your case. In our case, for example, we don't need to test. Well, we do need to test, but we do that using our community, which is a community of developers. And we can do that, but if your community is of people that don't really code, no, you can't do that. Right, but the results, as you can see, 9 web servers that never change for years is a pretty high value. I mean, we're saving hundreds of thousands, if not millions there. Garbage collector is a pain, and the more you grow, I think pretty much everyone hit that at some point. And then you can hire hackers and buy them 3 monitors. So that's that. Thank you very much. I don't think I have time for questions, but I'm going to be around at least until lunchtime, so grab me for any question that you might have.
Thanks a lot, Marco. We do have time for questions. A few.
Okay.
Sorry, this one's quite a technical one.
Sure.
I can see that that's ASP.NET MVC.
Yes.
What, version 4 or 5 or something?
Yeah.
What's your take on Microsoft's complete overhaul of their web ecosystem, and is Stack Overflow planning to adopt it anytime soon?
So we are following that very, very closely, and we're working with them on it. It's all in the public. If you go on the GitHub ecosystem site, you can see us commenting and giving feedback and designing stuff with them. Mostly because we do so many libraries, and so, wow. and so it's a bit, very interesting to them. Well, it's not there yet, right? So it's a great thing, but they're still building it. We plan to use it as soon as possible, but that looks like it's going to be years before it's actually complete. But yeah, I mean, it's very performance focused, something that .NET was not so good at. Other questions?
Other question?
Yeah, you were talking about these 9 servers. Do you have another 9 servers at a different location, like redundant data centers?
Yes, we have 2 data centers, but only one is active at any given time.
Okay, but do you have that?
Yes.
Okay.
I think we have one more. Okay. Thanks a lot, Marco, again.
Cheers. Thank you.